Today's webinars serves as an introduction to what promises to be an enlightening, enriching journey. Throughout this series, our primary objective is to provide you with a better understanding of AI from current trends, as well as how it might shape risk management processes in the future. We're going to explore not only the theory, but also the practical. So we will delve into the world of AI, unraveling its complexities and uncovering its vast potential to revolutionize the way we perceive and manage risk. When we reach the end of this series, we hope that you'll be better equipped to take on AI and risk management. In the spirit of fostering collaborative learning and meaningful exchange, we've gathered a lineup of engaging sessions and insightful panel discussions with experts. But before I introduce today's speakers, a few housekeeping rules. There will be a Q&A session toward the end of the webinar. So we welcome your questions throughout the session via the Q&A function. Please also give us your feedback right at the end of the webinar so that we can improve, listen to your needs. It's always useful to us. You will have a link provided on a slide at the end, or you can use the QR code. But now let's move on to our speakers. Today, I'm delighted to introduce our esteemed panel of experts. Let's start with women. Barbara. Barbara Meyer is risk management expert at SAP. She has a diploma in business informatics, a master's degree in law, and has over 30 years experience as project leader, expert, and manager in the enterprise software, electronic manufacturing, and printing industries. Barbara worked for 24 years in the compliance, security, and risk management field with a special focus on IT and legal topics, artificial intelligence, data privacy, and sovereign cloud risk management. Welcome, Barbara.
Thanks for having me.
Dan Adamson. So Dan is a co-founder of the company Armia and an AI entrepreneur. He previously founded Outside IQ, focused on AI for global financial institutions and supply chain risk. And he was Chief Technology Officer of MedStory, an AI search company acquired by Microsoft. His current company, Armia, performs independent assessment of AI systems and can provide guarantees for their performance backed by the Lloyd's market and by Swiss Re. They also provide a platform for enterprises to manage third-party AI risk. Welcome, Dan.
Thanks, Tiffany.
Josh Gerardin is the CEO and co-founder of the company Yields, which is started after having spent 15 years in algorithm development for high-risk and high-stakes environments. Yields is a software company that has built a platform to manage model risk efficiently. By championing model risk management, they aim to instill a universal understanding of its necessity, preventing the misuse of algorithm and making their use in high-risk environments safe and reliable. Welcome, Josh.
Thank you, Tiffany.
So thank you for being with us today. Your collective expertise spanning the fields of technology, risk management, and entrepreneurship promises to enrich our exploration of AI's profound implication for risk management. So we will now get started on the webinar, ready to explore, learn, and embrace the challenges and opportunities that lie ahead. I'm very excited to see where this series takes us and the insight we'll uncover along the way. Thank you all of you for joining us. Let's dive into the fascinating world of AI and risk management. Over to you, Dan. You will tell us about your journey into risk management and AI.
Yeah, thank you, Tiffen. I think what better place to start in this series than to maybe just talk about AI and its evolution. I've been working on AI systems for over a decade, and the definition of AI has changed during that time. But it's very important when we talk about AI systems to know that it's a broad field, that there are different approaches to AI and different definitions to AI. For the purposes of risk management, it's important to take a broader perspective and have a broader definition, in my opinion. So that when you're looking at AI risks, you can make sure that you encompass or include those types of systems under that umbrella of risk management. So artificial intelligence, while it's very broad, there's a field of machine learning that's well established. It includes several different approaches that you may or may not have heard of that might be very statistical. There's also a field that's neuron-based, artificial neuron-based. We'll talk about more, but you might hear the terms deep learning, LLMs, right? These are all actually neuron-based systems. I'm going to delve into a little bit about how those have evolved and work because that's all the rage right now. But it's important to note that a proper risk management program encompasses the broadness that AI includes around machine learning systems, for example, as well. So yeah, so on the next slide here, I'm just going to start with the fundamental building block of neural AI, and that's the artificial neuron. And those artificial neurons have weight, they have inputs that come in. They have a series of weights that weigh those inputs, and then they have a transformation function towards an output. And that's really the basic building block. When we talk about weights, those weights are trained generally to optimize what's output, the decision. The field has advanced to have layers of these neurons. And so you can combine those into a layer, and that's a simple neural network now where you have one layer of neurons. And that's the simplest type of neural network. The field quickly adapted to say, well, if we have one layer, we can actually have multiple layers. And that's when you have multiple layers, that's called deep learning. So that's essentially taking these layers of neurons, and those neurons at different layers might behave differently. They might have different behaviors, but you're generally passing the outputs of one to the inputs of the other. Sometimes there's recursion. So these deep learning systems have gotten more sophisticated with different architectures over time, but they're all based on this sort of layered approach. One of the more advanced types that's in the news today is called transformers. And so that's essentially this transformer based system where it's, in the case of LLMs, even more specialized, and it's a decoder-based system. So there were actually more sophisticated architectures that had encoders and decoders combined. We experimented with encoders and we experimented with just decoders. And it turns out that just decoders here, and this is a picture of one, are actually quite powerful and form the basis of LLMs, of which the most preeminently known is the ChatGPT, OpenAI's LLM. And so this has all evolved and will continue to evolve, but it's really all evolving from that basic building block. Why is this important? If we go to the next slide, because a lot of things can go wrong when you start to implement these in production or against a specific use case. There are a lot of things that you have to look at, a lot of different aspects, and it's not traditional software development because you have inputs and those outputs aren't defined by a discrete path. They're defined by the actions of that network and the outputs of that neural network, and very hard to define deterministically what's going to happen for all inputs and correspondingly all outputs. These systems also can be trained from day to day, and so you might have different outputs after retraining or feedback loops than you had the day before. So there's a lot of things that could go wrong. You have to think about the risks differently of these systems. And there's been some frameworks developed. They range from, they're very similar in nature, even though they range from 3 to 10 pillars, I would say. This is an example from KPMG. I like it because it has 10 pillars, and I can show you that it shows foundationally that data integrity is an important pillar. And but built on that, they have nine other principles. And sometimes these frameworks include sustainability. Sometimes those are kept separate as part of ESG programs. Sometimes these pillars combine some things, like transparency and explainability might be combined or separate depending on the framework. But it's important to pick a framework and know that they generally will include some key aspects like data integrity, privacy, transparency, and fairness and accountability. And why is that important? Because you then need to look at each of those when you look at a system and make sure that you're achieving a certain level of robustness there. So I'm going to show you a few examples in generative AI here, where we look at specific aspects of that system in regards to that principle, and we can see where things can go wrong, right? So in this first example around privacy, right, we know that these systems are trained on data sets, and those data sets can actually be leaked out. And so this is a great example of a text-to-image system where you could actually push the system, especially when it only had a few distinct pieces of content, but you could push the system to actually output the actual training content. And so that's disturbing if you don't expect it, right? And you have to be able to test for it and have to be able to measure this, and have to also understand the sources of your data and the risks there. So we're generally building on existing principles around privacy and GDPR, but adding to that, understanding that there are risks here around leakage. And the next example here that we have is around, if we go to the next slide, performance, right? Performance of these systems, they have gotten so convincing in their explanations, and they're very well spoken, that actually hides the fact that often they're making things up. For example, this is from a New York Times lawsuit against some of the large language model producers, the foundation model providers. And you can see that Google Bard here is very convincing with what it's saying. Unfortunately, it's all wrong and made up, right? And so it's mentioning the New York Times in several ways where New York Times didn't say or was quoted inaccurately. And so you have to be very careful and understand that this is a risk. Performance is a big category of what you need to understand and how to measure when you look at these risks. On the last final example here, bias, right? You have to look at fairness and bias. If we go to the next slide here, there's bias around it learning from its data sets. And because generative AI actually is forced to pick a path, it actually can perpetuate or exacerbate those biases. In this example, regardless of how the question's asked, the system's actually always assuming it was the nurse who was late, and that the nurse was a female. And so you have to be very careful, understanding that these systems not only take the inputs of that data that might be biased itself, but then can exacerbate them. So if we go to the next slide here, this has gotten quite complicated when we look at the landscape. Understand that there are regulations coming in internationally. Of course, the EU AI Act, we'll talk a lot more in the series, I'm sure, about this, nationally as well. Provincially or state legislation as well. Colorado just had an act that was passed, for example, and then even locally, right? The New York City has a local law 144, which is around bias and fairness for HR systems specifically. And so you have these regulations coming in, you have emerging standards coming in, BSI, ISO, NIST, these are all standards that are being worked on. And you then have emerging best practices that follow suit, and we have assessments and audits as well, and certifications. This can all get quite complicated, so it's very important to have a touchstone or a bit of a Bible that your corporation develops. So we'll talk about some of the lingo around that if we go to the last slide here, and some of the terminology. This would be some of the basics. Barbara's going to go into talking about risk management and different aspects of this in more depth, but just to give you some of the terminology and key points to what should be part of every organization's responsible AI policy. Sometimes it's called a RAY policy for short. Sometimes it's called a trustworthy AI policy or trustable AI policy. But they generally work the same way. They require an inventory of models. And we use the term models. There's a blurry line between models and systems, especially with third-party models. When you're buying models, they might be entwined in a system, and it's hard to separate them. So you have to think of these as such and know that there's differences. There's generally an assessment part to the materiality of the model. So how impactful will that model be? What are the potential harms that could, how is this a trivial model that is just optimizing minor things in the background used internally, or is this exposed and there could be grave harms? Maybe a credit lending model, for example, if it gets it wrong. So, and where's the threshold for your organization around what needs to be independently assessed, and then what level of internal assessment? Generally, they also define a risk framework, which we talked about, right? And what are those important pillars? You can leverage what's out there already. Ray, the Responsible AI Institute, has a great framework, for example. I showed KPMG's, but you can take that and tailor it and include that. There's controls as well. What controls do you implement? There's the definition of accountability, not just in the development of that system, but also once it's out in the wild, right? Once it's in production, how is it maintained, for example? What triggers are there? And of course, how do you train both the developers against these practices and the users? That's very critical. If, for example, you have internal users and they're using a system, there's a well-known principle of machine bias where you can assume that these models are correct. And like we just showed, and Josh will show different use cases, it's not always the right assumption. And so you have to actively train those users. But yeah, so those are important, as well as how you maintain these. And then acceptable use policies, right? And Josh will also talk a lot more about the different developers and users and the life cycle of these models shortly, so I won't go into that. But very important to understand that life cycle and map out who needs to be trained at what portion here, and how they react within this policy framework. So, and the last part is that today, for the first time, probably users can take AI systems, your employees can take AI systems and use them outside of your procurement cycle. So they can swivel chair to ChatGPT. Probably you might have firewall controls to prevent that, but they can swivel chair to use AI in a Bing search, right? And so it's very important that you start to incorporate AI acceptable use policies, either in this policy itself or on its side as an employee policy. And that's something that's evolving over time here, but something that we see the need for now. So with that, one key take-home point I'd like to sort of leave you with is that this RAY policy should become your touchstone, your Bible, and it can evolve over time as AI evolves and the risk landscape evolves. But if you have that, then, for example, take Josh when he talks about different examples. You can take those examples and look at them and say, okay, well, how would my policy have prevented this risk or minimized it, right? And so really take that policy as your sort of cornerstone for your work in this field. Thanks, Stefan. Back to you.
Thank you, Dan, for this clear introduction and really stressing the criticality of having this responsible AI policy in place. So now turning to the integration of risks into some uses, I would like to hand over to you, Josh.
Thank you, Tiffen, and thanks for this invitation. Indeed, today I would like to talk a little bit about how users may interact with AI systems, what are the different roles, what are also some of the key applications, and then maybe give a few examples of risks as they materialize by using the application before handing over to Barbara, who is going to dive a little bit more deeply into AI risks. So let us first go to the first slide indeed, which highlights an example of what we would call an AI lifecycle. So AI systems, such as traditional software, obviously is managed according to a number of principles. And a very important one is, of course, the process that you have to follow from initiation until retirement of the application itself. And the example that you see here is a slightly simple implementation of such a framework or such a process. But as you will already see, there is quite a few different stakeholders, even in such a simple example, which already highlights the need for clear communication, and has then also highlighted clear processes to make sure that everyone understands their role. So if we would think about, say, an initial project in an organization who would like to build a particular AI use case, of course, it's often very probable that some of the elements of the algorithm are going to be either procured elsewhere, or perhaps people will select some open source solution. But nevertheless, there will always be a certain amount of fine-tuning required. So that's why you will almost always have the different phases before directly using the application and production. Good. So if we would take any generic application, the starting point is always going to be a business requirement that you have. And during this initiation phase, one typically already associates a product owner to this project who is going to drive the entire process forward. And in that initiation phase, it's key to already think very carefully about how to quantify success in such a project. Especially with AI use cases, such a definition of success might not always be trivial. It is easy when you are building something to forecast some future event, but it might be much more complicated when the use case itself is slightly differently defined. However, defining properly the key performance indicators for such a process is very important. Now, once that initiation phase has passed, typically there is going to be a certain amount of development, or at least some fine-tuning. Now, when you build AI applications, contrary to standard software, an extremely important aspect is to gather the right data to make available high quality data so that you can train the AI application on it. So that's why a considerable amount of time and effort needs to be spent there. Much more almost, I would say, than modeling itself, because many of the traditional machine learning algorithms are already available fairly easily. Now, what one obviously, like in software, often does is to end up with a prototype that then needs to be tested. What is key in an AI use case, or what is a bit special in AI use cases, is the fact that sometimes testing can only happen in the real world. So if I'm building a predictive model, something to forecast the future, then I can do what is called backtesting, which means that I will compare historical performance with what actually realized. And this allows me to evaluate the performance of that model already without ever having to put that into production. On the other hand, if I build, for instance, a recommender system, and a recommender system is something that you probably know if you have, say, Spotify or Netflix. At some point, the application is suggesting other music, other movies that you might like based on your history. So this is a recommendation system. And that type of system is much harder to backtest, because it's very hard to simulate how I would behave at a certain point and what would be the impact if I would have made a different decision. So in order to manage this, one sometimes does some very controlled pilot usage of a prototype of an AI application. So you run it in production, but as controlled as possible to limit the risk. And that's very specific to AI life cycles. And this is what you see here in this box, and the model user who would be responsible for that use. And then after this type of initial testing, there's going to be typically a production deployment. Once an AI system reaches production, it still has to be monitored continuously. And the reason is that the use case itself, or the data on which the application is triggered, might evolve over time and might require, for instance, a retraining at some point, which is why the monitoring aspect of AI applications is very key. And as you can see, a model lifecycle is not very much of a cyclical or sequential event. It's a process with a lot of different stakeholders, with many feedback loops, and that's why communication really is key. So with this, let me go to the next slide and describe a few use cases. This is an overview that has been made some time ago, and that highlights some of the traditional use cases that we see when looking at AI applications. I won't cover all of this, but let me perhaps focus on two or three examples. The first one I'd like to highlight is what is at the top right corner, predictive analytics. So this could be, for instance, use cases which focus on predictive maintenance. It can be all kinds of predictions that you try to make for the future. So we call these type of applications often supervised machine learning systems, because they are trained on historical data. They're basically trained on examples. And the idea is that if you give the neural network, for instance, enough examples, it's going to discover what are the key patterns to become better. While training, you obviously can also very easily measure the prediction error, because you simply have to compare what was the outcome ultimately versus the prediction itself. Now, another very rich set of use cases is so-called unsupervised machine learning algorithms. And unsupervised means that the algorithm is trying to discover the underlying structure of the data itself and come to conclusions. And a nice example of this is fraud detection, where often that type of unsupervised algorithms are used. When you are looking for fraud and, for instance, transactions, one aspect of it is that you are trying to identify atypical behavior. And in order to do so, machine learning algorithms or AI applications are going to be trained to first quantify how regular a particular transaction is. And if something then is completely different, then it will be marked as an outlier or as an anomaly or as a potential fraud. So this type of unsupervised algorithms are typically used in this context. They're also often used in whenever you need, so for instance, segmentation, which means that you are trying to identify clusters of similar behavior together. And maybe a final example that I wanted to highlight is what is here listed as real-time operation management. So in logistics and planning, very often there is a number of rules that have to be incorporated, and learning to play according to rules as optimally as possible is the realm of so-called reinforcement learning, which is a third category of machine learning and AI use cases. And reinforcement learning you have probably also seen in action when you have read, say, the headlines when, for instance, when DeepMind was able to, as for the first time, beat the world champion in Go. So this is an example again of reinforcement learning. So as you can see, there is plenty of use cases, and what is maybe interesting to remark as well is that with the advent of generative AI actually those use case categorizations are a little bit are a little bit less clear, because obviously if you get say access to ChatGPT as one example, you can basically ask it any type of question. Of course, as Dan already highlighted, it's not always clear how truthful the answer will be, but at least it's much harder to clearly define the context. And in this also lies a big risk. So when you build applications, when you build use cases, it's extremely important to define in what context it's going to be used, so that you can also identify when the AI application is fit for purpose. In the context of a generative AI application such as ChatGPT, this might be harder because it's harder to control the inputs that you and the questions that users would ask to the system. Which brings me to the third slide, the final slide for my part, which is about what type of risks materialize when we are using AI applications. Now, I would say that a first important risk is related to reputational risk. And this traces back to the fact that many of these AI systems are built on extremely complex algorithms, as Dan already indicated. And because they are so complex, it's sometimes very hard to understand how it came to a particular conclusion. And when that's the case, it's also very hard to detect whenever the system might be biased, again, because it's rather intransparent how the conclusions are drawn. Of course, there are many metrics, many controls that you can put in place to limit those risks, but still the fact that an algorithm is much more of a black box remains an important issue. And one example of this is of such a risk that materializes, a fairly well-known example. It's already a few years old, but Amazon at some point developed an HR application to screen CVs to hire developers. After a while, it was discovered that this this HR tool showed a bias against women. And the underlying reason, of course, is that Amazon was using a historical data set of many decades long of CVs. And because of that old data sets, some of the data itself was biased. And this can be kind of this type of behavior, then the fact that the machine learning algorithm infers bias from historical data as an important risk. This can, of course, be mitigated, for instance, by making sure that the data on which the application is trained is more equalized. It can also be that the prediction of the algorithm is corrected afterwards, before it is presented to the user. But as it often is not clear how this application has been trained, what are the underlying assumptions, as this is not clear for users, the risk is, of course, that if they base their decisions on the output of the algorithm, that there might be issues there. A second example of, say, user risk is everything related to the accuracy of the algorithm itself. What you see here in this picture is a rendering from Microsoft Flight Simulator. This building, which obviously does not exist, is called the Melbourne Monolith. And the reason why this building is shown here is that when rendering the Microsoft Flight Simulator scenario, actually geospatial data is being used, and there was obviously an issue with the data. So in this case here, it's kind of funny and fairly easy to detect that there is a problem. However, if you have high-risk applications, for instance, if you want to, say, balance the energy grids based on incoming data, it's quite important to make sure that there is sufficient controls to make sure that whenever inaccurate data would arrive, that actually actually this is kind of properly controlled. Another example for which I don't have a picture here is iSpace, which is an space agency in Japan, actually recently crashed a space lander on the moon, and the crash actually was caused by the fact that a sensor was showing unexpected inputs, and because of this the sensor was switched off, causing the moon lander to crash. So it's very clear that making sure that you control properly all the data is extremely important. The converse is also true. If you have a lot of data and you fit an extremely complex algorithm to it to fit the data as precisely as possible, you might often end up with overfitting. And what that means is that whenever then the algorithm has to extrapolate in one way or the other, that you end up with very strange results. And to a certain extent, hallucinations are a type of overfitting, and hallucinations in the sense that Dan highlighted. So these are just a few examples of how risks might materialize. Barbara, the next speaker coming up, will give you many more details related to that. And with that, Tiffen, I hand over back to you.
Thank you very much, Josh, for these very clear examples. And we can see that there are very diverse AI applications and risk related to them. So it's very important, as you mentioned, that we have high quality structured data that we monitor regularly. So I will now hand over to you, Barbara. You will take us through the relationship between AI and risk management. Over to you, Barbara.
Thank you. I can switch to the next slide. Thank you. To have a little playing field, we have to understand, why is AI risk management important and different, so that we are all on the same page. There are three main areas, three drivers. They were already mentioned, but I just put them into the three buckets. The first is what we saw. We saw from Joe's, we saw from Dan, hallucinations and biases. Joe's showed us also the different risks. So here we are focusing on AI vulnerabilities and our answer to that. So standards, especially security standards, security policies and controls. And the second is AI for risk management. The AI for risk management is the other way around, and we just saw it from Joe's. So things like fraud detection and risk management in analytics. And the third is development of AI, so the adoption risks of AI. By the way, I see that you have an old version of my slides in here. So sometimes my text may differ a little bit from what you see here. So when we go into these three buckets, we have to see the huge difference behind is that we have that huge amount of data. Dan explained it to us from the basics. He showed to us a system which has one layer and explained that. But the overall system, the LLMs, that is with a huge amount of data. Already GPT-3 was trained on 40 terabytes of data. GPT-4 was trained on roughly 13 trillion tokens. And by the way, when I say token, I don't mean money. I'm talking about 4 characters. So token in the area of AI is always 4 characters. So meaning 10 trillion words. And a trillion is a one with 12 zeros, meaning no possibility to have any quality assurance. And what makes it even worse, and Joe's explained it very much, the development requires live data, productive data. So AI needs real data. And productive data often contains personal data, requiring data governance on business, technical, and ethical level. On the technical level, as said, the development system shares now productive data, meaning all the controls we normally had in the productive system, roles, monitoring, vulnerability scans, and so on, they are now required for the productive system, not only, but also for the development system. And on business level, we have all these legal requirements already in. So the legal reasons for collecting personal data must be documented upfront by law. And we have to have that in mind. Where does the data come from? How do you ensure its validity? And what do we do with the results? And that has impact also on the ethical level. How do we ensure that there is no bias? And data supply chain is, of course, affected by that. Kindly switch to the next slide. Yeah, unluckily, as said, that is not the latest version of my slides, but I simply go on. Hopefully you can find what I'm talking about. We have 4 buckets. We have the risk sources on the left hand, the vulnerabilities, the red ones, and the risk mitigations, the green ones, and the trust categories. So here we see the current state of the AI security and risks. So the sources, the risk sources, let's take one example. We have models coming from open source with usage of public data sets where we do not know where the data come from. Maybe the data was poisoned. And that source is driving towards the real vulnerabilities, the red one, and that exist. So can we trust them? Could be there a Trojan AI model? And as well as generative AI for generating phishing. All these existing vulnerabilities must be mitigated. And for instance, proper alignment of the data sets, debiasing, as already described by Jos, and so forth. That comes down to our 4 areas of risk management. So the overall trust categories: privacy, data privacy, ethics, legal and regulatory compliance. So we do not only have data privacy to care of, but also intellectual, thank you so much. But also intellectual property and copyright. And then, of course, the defensive measure. Here you can see on the upper corner of the slide what I just mentioned. This, I had the training data coming from public data sets pushed into the open source model, and that might create a Trojan AI model. So thank you very much. Kindly switch to the next slide. Yeah, so on the previous slide, we saw the risk identification with the technical vulnerabilities. And we saw adoption risks in the 3 categories. We have human risks. So, for instance, irresponsible use of AI. We saw the technical risks and we saw exfiltration risks. Exfiltration risks are the ones, for instance, data mishandling. And my colleagues already mentioned that we have to have a methodology to mitigate. And we saw that the culture training is crucial. So risk identification, established methodology, And the third is that you always have to have core guiding principles. And this is what we are focusing now on. You always have to have in mind, AI does not think. It just predicts. It's all about probabilities. And if something is based on probabilities, there will always be mistakes. And it's always based on past data, the training data. So you will always have mistakes. And whatever you do, you will always have bias in. And what makes it even worse, there is a huge difference. I know in the audience, we have a lot of people come from insurance companies. So you studied once mathematics. You might be aware of that there is a huge difference between correlation and causality. But in the world outside, there are a lot of people that aren't aware of. And we have to clearly show them and again and again and again explain. Correlation is not causality. And that is the reason why we should never, ever replace. We should always use AI as assistance and keep the human in the loop. By the way, I'm talking to European companies right now here. I think most of you are members of European companies, at least doing business in Europe. So we all have to obey to the EU GDPR. And we all know about Article 22 of EU GDPR. So we have to have the human in the loop. So always don't do assistance. Always do assistance and don't do replacement. You have to have someone still in the loop. And my colleagues talked about the different roles in AI. So the responsibility is never ever in AI solely up to one role. Yes, AI was once developed, but using it responsible and doing responsible operation in the cloud, that is all in the shared responsibility. So we have to have shared responsibility established for secure and responsible AI usage amongst all stakeholders. And this is what is also reflected in the AI Act, in the upcoming AI Act, which is currently still a draft. As mentioned already, we have to implement technical and process controls as proactive AI risk mitigation measures. That not only affects data protection, we also have to take care of intellectual property. There are still some questions unsolved. Who is really owner of the text produced by an LLM? Is it the model owner? Is it the one that, for instance, with training, retraining, and prompt training, put data in? Who is it? That is still not solved. And what we always have to take care of, proper consent management. So GDPR again, we always have to collect the consent upfront, meaning you properly have to assess your use case before it is developed. As we learned, the data we are bringing in for the use case might already be productive or will be productive. And that brings me to my last slide. Thank you. Your takeaway for today should be 2 buckets: solid foundation today and plan for the future. So establish security standards and AI policy. So found a solid platform. You have to have at least in place a policy for data protection and privacy with focus on AI topics, a special policy focusing on, I always take the word trustworthy, and it's established with ACP. I have to confess that I have my issues, for instance, with explainability. And you have to have product security standards in case you really produce AI. Why do I say so? Most probable, I mean, everyone is trying to be part of the AI world. Everyone is striving at that, and you don't have to have the best AI system. If your AI system is not trusted by your customers, then no one will take that one. So the key differentiator is really build an AI system and really use it in a way that the customer can trust the data to that system. And that is, I mean, I'm from ACP. You might have seen that the stock really increased in during the last weeks, and that is simply the reason why, because we are headquartered in Germany. We simply say we stick to EU GDPR, and we have all these policies already established for years and years. We engage in industry frameworks and regulations, and we really confess, we strongly believe in trustworthy AI. We strictly do everything consent-based. So we collected consent from our customers for using all the data upfront. And that's the reason why the people trust in our business AI. So that is a strong evidence for that. My colleagues already managed the risk management frameworks. I can strongly recommend the NIST AI framework. That is very helpful in bringing AI risk management up in your company. And then, as said, plan for the future. So plan for a complex and regulated future. I already mentioned there are several open questions still there. Make your documents living documents. Establish, for instance, steering committees and maintain them so that all your AI-specific use cases are re-evaluated each and every time. So train and educate and develop Gen AI-specific security standards. Thank you very much.
Thank you very much, Barbara, for your insight. So I think, you know, what you said, AI does not think, it predicts. It's about probability. It's based on past data. So we need to be conscious of that, and the trust is very key when you develop AI applications. So thank you very much to the three of you. We will now move on to the Q&A, and I see that in the chat there are a couple of questions. I will take some of them depending on the time that we have remaining. So let me double check what we have. So I have a first question for you, Dan. Do you think that companies will have employee training on AI similar to the cyber training, or it can be, I think, answered from the three of you, because you know that we've got now it's quite mainstream that in company we've got training on cyber. Do you think that in the future we will have on AI as well?
Yeah, and I can start. I think the reality is some of the best controls and tools for detecting potential harms and for recognizing risks are at the end user. So educating your employees around what to look for, around things like bias embedded into these models, around hallucinations, around fakes, right? There's your employees are your first line of defense. and your users are your first line of defense. And so sadly, I think if that means that there's yet more training to be done, this is the reality in today's world. Whether that evolves into a combined sort of cyber AI risks training, because it overlaps to some degree, we'll see, but it's definitely needed now.
Training is important. Josh, you wanted to
I
ask?
just want to,
Yes, please.
to add here that indeed I fully agree with Dan. So at Yields, we are working today primarily in financial and insurance sector, which is regulated, which already has regulation, which is called model risk regulation, very similar to AI risk. And there as well, it's extremely clear that a huge important driver is that all the users have to be fully informed about the limitations and the assumptions that the model has. So something similar indeed will have to be done on AI cases. And the reason for this is that most of the incidents that we have seen in the financial sector were driven by the fact that models, mathematical models, were used in a context for which they haven't been designed.
Thank you. So another question, how can organizations and individuals stay informed about emerging AI risks and best practices for managing them? It's true, you mentioned, George, that it's going very fast. So how can organization, I think probably organization, it's very important, they stay, informed about emerging AI risks.
Maybe I take this because
If you want, yeah.
we are issuing our AI software and our AI use cases to other companies. We have security papers. I just sent Charles, for instance, one which you can distribute amongst the listeners. So we do trainings, not only for our employees, but also for customers, for partners. We have research, AI research. We act as speakers, and we issue papers. So we try to get as much hold as possible of our customers and always explain.
Okay. You would like to add something?
Just I'll just add.
You first, then.
Yeah, go ahead.
I was going to say the most important is to obviously subscribe to all the upcoming webinars of Ferma on AI risk management, clearly. But other than that, what I always find a very good sort of information is incidents that have happened. There is an AI incident database, for instance, which is a very good source of inspiration if you'd like to learn about upcoming AI risks. With respect to best practices, I would say that looking at, say, industries, for instance, finance, where this has been implemented already for quite a long amount of time, might also offer some good data points. And there is definitely many documents already available, some of them on our website as well.
Yeah, and I'll just add that it's also important to stay educated around the regulatory environment as well, because that's also evolving rapidly, as we said, at multiple layers. Armilla has a newsletter, so you're welcome to subscribe to that. We cover these points, and then in our third-party risk management program, it's important that you understand that risks might evolve for your vendors as well, right? So as you've implemented and done a assessment on day one, that could change as there's an incident, for example, as Jo said, and so important that you have your pulse on what's happening in the industry, and then in particular with your vendors, of course.
So there are plenty of sources to be kept regularly informed. How would you convince experts, data scientists, model developers that building a solid risk framework around their system is something that will become key in the coming months, years? Who would like to take? Maybe Barbara, would you like to take this one?
Yeah, maybe I start, because I think we do not have to convince. As said, if you want to be successful, the key factor is really that the people can trustworthy AI, and they won't give you your data. So anything which will be used for, of course, I'm talking about enterprise purposes, in order to do any deep fake, then you do not have to build on trustworthy AI. But I think it is simply that everyone will see that there is an association whenever it comes to enterprise AI, business AI, it must be trustworthy. That's self-explanatory.
Okay. I see that we are running out of time. Unfortunately, there are many questions that we will keep. And if I may, I will send them to the three of you. If you can take the time to answer them in written, and then we can post them on the website so that you are sure that your questions are answered. Meanwhile, I invite you to either click on the link or scan the QR code to give us your feedback, because as I mentioned in the introduction, this is a series of webinars. So we really want to be able to meet your needs, and we will use your feedback to be able to develop really customized, I would say, webinar for you. So thank you very much. The next webinar in this series of AI specified webinars will be on the no, this is not this one, sorry, on the 18th of April. So watch this space for further announcements. But on the 28th of March, Fermat is going to have another webinar on a very interesting topic, which is about cyber reporting stack. We will do it alongside WTW. So also watch out about the registration to this webinar. You will receive the replay of this webcast. Of course, the slide will be also available, as well as the answers to the questions that we have not been able to reply online. And thank you everyone for joining us, taking the time to view our webinar. Thank you very much to our speakers, and see you next time.